Hi, Stuart here. I've been asked by a bunch of people how I do cloud architecture, how do I think about it. And so I've decided to take my long running kind of 1, 2, 3 scheme and turn it into a short YouTube video, which is what this is. So here's the thing. I've pretty much been doing this since before cloud became a word. Big data center projects are very cloudy in some ways. So I have made pretty much every mistake that you can make, so you don't have to. Yeah, that's the reason. But I wanted to kind of hit the highs of things that I have learned painfully over the years. It's really easy to make false equalities and say, oh, well, that's just like that, but it's got this thing. Well, yeah, but at enterprise scale, tiny differences make a huge, huge impact. And that idea comes from chaos theory, right? The initial starting conditions can result in dramatically different outcomes. So it's important that architects and people who aspire to be architects break themselves out of that mental mode. The other thing is, and this used to be a lot more true for me than it is today, and that is it's all too easy to get caught up in the flavor of the day or be lured by shiny resume bait. You read some article on the interweb, which, everything is true on the interweb, so that's cool. And it says, oh, if you're not using Fuzzboom, you're just not doing good architecture. Or if you're not using the Gorf pattern, you're just a bad architect. So, patterns and choosing technologies and stuff, that happens a lot after architecture with a capital A is done. That's implementation or design, but, shouldn't do it too early. It's so easy to say, wow, I'm not really sure about this. I'm going to do a POC. And then, quite unreasonably, the customer expects you to ship your POC, which, isn't enterprise quality code, probably doesn't have any of the desirable enterprise scaling and reliability and observability things. I refer you to the 12-factor app and on my many, many videos on how enterprise implementations go horribly wrong and how not to have that happen. And so, I don't like proof of concept as a word. I like the word experiment. Because it sets up a better mental thing for people. And you have to keep repeating to especially the non-technical stakeholders that just because you have potentially solved this particular business problem or issue or approach, that doesn't mean that you can take that and just run with it. So, that leads to the next thing, which is bad architecture is so hard to fix. And it's almost always the result of not paying enough attention to what to do in each of the 3 phases of a project, and when to do it and how deep to do it, and not paying attention to the non-functional requirements or letting the business users sort of blow you off with, well, we don't know that. We don't know how many users or transactions, or we don't know what the expectation of reliability is or your service level agreements. Don't tolerate that, because they're just setting you up to be miserable during the implementation. Now, if you're going to do the architecture and run, you might get away with it the first time. But, eventually the implementation team will hunt you down. And the internet's a thing, and karma is a real deal. So, and the last thing is, stakeholders come in lots of different flavors because humans come in lots of different flavors. And there's a group of stakeholders that always want to say no to everything all the time. And you just have to be able to negotiate with them. And there's a set of stakeholders that we call idea hamsters, right? They're just all over the place. They can't settle, right? And then there are the stakeholders who are such subject matter experts in this little pie wedgie that's 5% or 10% or 15% of the entire project, but looking to them for what the point is not going to be useful. So it's really important you find yourself an executive sponsor who in very few sentences, like one paragraph, can articulate what this system does and what it's for and what does victory look like. And we're going to talk about that a lot more. So just like start from a place as an architect of not falling into these. These are dreadful traps that will absolutely torpedo your success on whatever project you're embarking on. The other thing that I just have to say is just done relentlessly wrong on almost every project I'm on, unless I am the undisputed king of all I survey, which never happens. And that is that people don't use the item tracking system, and really the tool doesn't matter as long as you can express these ideas, right? So I like ADO, but you can do it in GitHub or you can do it in whatever your favorite tool is, but do it, and do it with discipline. We're going to talk about discipline later. So at a high level, right, an epic should be the 4 journalism questions. Why, who, where, what, how, right? And the most important question of all is, how does it end? And what does victory look like? And in order to do that, there has to be a reason. Why are we doing this? If someone cannot look you in the eye and give you one sentence for why you're building this system, be very afraid, because they don't know. This may be a vanity project or some sort of marquee project, and you can spend ballistic amounts of your customer's money. And here, by customer, I'm in consulting, so I code for other people. I code so you don't have to. But it could be an internal customer, right? It could be for your peers. They're all customers, right? So if someone cannot articulate why we're doing this and who we're helping, that's bad. And where the users are and where the system's going to reside, super important. All right. So the epic should speak to those things. And if it doesn't, that's not good. So then, if you do domain-driven design, which I prefer, by the way, got a nice video on domain-driven design. B, there's lots of good stuff out there. C, yes, there are alternatives. The point isn't the process. The point is the result. And domain-driven design has helped me deliver a better result by allowing me to get right to the areas of conflict really quickly. Because when we start drawing bubbles on a whiteboard and somebody says, oh, no, that belongs over there in that bubble, and you go, oh, but why? And then you realize that the two sets of stakeholders can't agree on the definition of something really important. It's just such a good tool for me, right? I love DDD. I find it useful. It helps keep me out of trouble. It helps keep me organized. It helps me communicate with the stakeholders. It helps me communicate with the teams. I think it's dead easy. I've got lots of videos on that, including one about how to draw diagrams, like know when to stop. So, each feature, an epic is going to have lots of features, and each one of them should represent fundamentally a DDD domain or shared context, which defines a subsystem or a subsystem of a subsystem and explains its role and tells us how we know we built the right thing in the right way, and anything else we really need to know at a high level, like special concerns. And then, the 5 item building blocks that are actually actionable are stories, right? What are we trying to do? Bugs, it all went horribly wrong. Tests, describing how we're going to validate that the story we told is right. Risks, which I keep seeing people put into an Excel spreadsheet instead of into their tracking system. And the problem is then you can't really associate a risk with a feature or features, right? Because these things are typically many to many. It's just a bad thing. You should be able to do a risk register by running a specialized query on your tree of items, and you should get a list of all the risks, and then you can filter that down by feature, Epic is the project you're working on. And then, we need a way of keeping track of requests. Please go build this for me. Please go provision this piece of infrastructure for me or whatever, right? So in each of the 3 steps, we're really looking to, in step 1, tell a story of the epic. In step 2, tell a story of each subsystem definition, because that's where design happens at the feature level, right? Architecture with a big A happens at the epic level. Architecture with a small a happens alongside design at the feature level. And, the implementation details, what I like to call bagatelles, are kept track of in the items. And there should be lots of items. And I'll say this now, and I'll say it again. Make it a rule that A, everything must go in here, and B, if it's not in here, it doesn't exist. You cannot be held responsible for things that are not in the tree. And then don't fall into the trap of making a user story for security or for performance or whatever. Those things are requirements told in stories, validated by tests, and, if they fail to meet that expectation, they're bugs. So NFRs and other metadata should be in your tag cloud, and almost all the big boy pants systems that you could use to do this have tag clouds. You can add a tag to any of the item types, epics, features, stories, bugs, tests, risks, requests, whatever. And you can have more than this, and you can have, but I wouldn't have less than this, right? This is these 7 things, Miller's number of things, is, it turns out, the sweet spot. Because if you start having too many item types, then people are going, well, this is a blah, 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 and then you start, mincing the definitions really fine, and at that point you can't taste the soup. So less is more, but too much less is, So people managing the project need to be able to pull up a risk register. Teams that act as service bureaus need to be able to find all the requests. Developers and QAs and InfoSecs need the stories and the bugs. And, everybody needs to be able to assure that we're testing some key scenario that we're telling in the story, because there's an accompanying test. And sometimes the test item just points off to source control and says, this is the automated test that's associated to testing this feature. And notice these things can be linked to each other, right? I can make a user story and then go, wow, there's a risk associated with that. And transitively, right, it is related to the feature which rolls up into the epic. So again, these things are many to many, including tag clouds. So just it's an epic fail if you can't do this with discipline. More about that later. Tracking item trees. There should be only one. It's on a project, looking over someone's shoulder, and they had 3 different tracking systems. One for bugs, one for stories, one for everything else. And I thought to myself, how can you relate those things to each other except manually? How can you query across all of them in any kind of sane way? And they had succumbed to best of breed disease. They were told that XYZ bug tracking was awesome and requirements management tool foo was awesome, and that they should, even though they had tools that would let them do all of this in only one place, they had it scattered all over. And that's the exact diametric opposite of what you want. In the same way that you don't want documents and spreadsheets and things like that that are not attached to tracking tree items, right? You shouldn't have more than one tracking tree. That's what I call them. They used to be called lifecycle management tools or whatever. So Azure, DevOps, Jira, things like that. Those are item tracking trees. And, you know, I know those of you who have watched a lot of my videos are sick of me saying this, but Eric Siegel nailed it, right? Just can't have things in more than one place. It just doesn't work out well. It's going to cause you pain. A place for everything and everything in its place. So here's the high level cycle, right? And fundamentally, what is the mental process that we are exercising? We're exercising an OODA loop, which is just a high level way that cognitive scientists think about how humans solve problems in productive ways. So we observe, we orient, we decide, and we act. And I've got I've got a video on this, and you can go read excellent articles on OODA looping. But fundamentally, the underlying process behind everything we do should be an OODA loop. Because if we skip any of those activities, right, if we're not paying attention, if we're not figuring out what the actual problem is, which is orientation, and if we're not deciding between the alternatives and then executing on that and then seeing what happens, right, that's an OODA loop. If we're not doing that, we're not going to succeed. It's going to be hideously painful. And again, I'll keep coming back to this. There is no perfect tool. There's no perfect programming language, no perfect database, no perfect queue, no perfect anything. But pick one. Pick one. Right? And then just live with it. If it does the 80%, you can figure out the 20%. It's not the technology. It's not the tooling. It's the people. Getting rid of all the people on my project would make all my projects go much better, but I can't build things at enterprise scale with millions of lines of code and hundreds of deployable units and tens of thousands of cloud nodes without big teams. And so, I'd rather make their choices as small as I can make them. Remember that in my philosophy, one of the things about being an architect is looking at all the things that could be and deciding what will not be, right? Saying no is a big part of our job. Saying no in architectures is a big part of the job. So we do requirements gathering, and we refine those requirements and understand them using DDD. And that's the investigation, analysis, pre-project planning, ideation, whatever you want to call it. I call it step 1. High-level architecture, technology choices, and design is step 2. And step 3 is implementation. And we're going to talk about each of these. But fundamentally, one tool, and don't forget to make sure you're exercising the OODA loop for everything. Right? See what happens. Decide if you have a problem or not, and state the problem, enumerate the alternatives, decide an alternative, act on that alternative, and see what happens. That's just so fundamental to being an engineer. I can't believe this didn't become a thing until recently. Different forms of this, by the way, go back 40 years plus, but this is the clearest articulation of that I've ever seen. So I'm a fan just because it's simple to explain. So requirements mapped onto domain-driven design. So who are the people in our neighborhood? We've got requirements givers that are business stakeholders in standards and compliance. And that can be standards and compliance, could be lawyers. They could be people who do licensing or procurement. They could, which, tell you what technologies you're allowed to have. They could be regulators. They could be InfoSec, although I have InfoSec broken out because they have to straddle kind of the divide between requirements givers and requirements analyzers. And, business stakeholders come in lots of flavors and they each represent their thing. And what you want to make sure is that you have identified the group of SMEs for each of the areas that are going to become what? Features, right? Or domains in our domain-driven design. And you got to identify who the owner is, like who is the decider. Because you can be in N number of meetings and fail to come to a consensus. And if you do not have one human that you can go to and say, or be, pick one, then you are well and truly in deep soup, my friends. You're in a lot of trouble. So we need architects, we need QAs, we need data architects and DevOps and InfoSec to help us build this out. The architect is responsible for driving the coordination of all the other roles and for making sure that we end up with the outputs, which are the domain-driven design, in my case, and artifacts, but whatever architecture artifacts that you're cool with, you must emerge with a data dictionary or glossary, whatever you want to call it, but the requirements givers are going to have a unique vocabulary for their business domain, and they may use words that you think you understand, but you so do not. So having a glossary and then showing it to them and go, did I understand that right? And then having a data dictionary that talks about, what the cardinality is between things. Oh, orders can have multiple order lines, and each order line is related to one product. Okay, gotcha. Right? That's part of a data dictionary glossary kind of thing. And that tree of tracking items, right? Got to have, if you exit this phase without an epic, many features, and a fair number of the other item types, as you have a discussion about something, you go, oh, there's a non-functional requirement, or a condition, and I need to write a story around that, or the data center could be overrun by Bigfoot. So we need to have a plan if that happens. That needs to be a risk, right? So the tree is really important. And again, you want to aim for 80%. And fit change in process into the plan you come up with in subsequent phases. Things change. That's an invariant. But if you can't get to an 80% because your requirements givers are inducing churn, or your peers are inducing churn and they won't settle on something, well, that's a big red flag. You're just so in deep trouble right at that moment. And you should just put the brakes on it and figure out, A, who the decider is, and B, for technology stuff, assuming that you've complied with all the other requirements, you really are the decider if you're the architect. So nobody ever built good anything by committee. There has to be a person who wears I'd love to come to this collegiately, but if you put a gun to my head, I will decide A or B when it comes to a technology implementation. Again, architect's job, big part of their job is saying no to things. how does it end, right? When you're at 80%. And your tree is filled out and your glossary is filled out and you have pretty pictures with bubbles and arrows and interfaces and, you know. When you can go to the people who are going to give you money to do this, and in 20 minutes, 20 minutes, you can explain what the business system is. So you can do the 5 journalism questions. You can do the high-level concepts. You can describe the high-level subsystems from a business context. And you can start to talk a little bit about the technologies. Like, we're going to build this in AWS, or we're going to build this in Azure, or we've identified from InfoSec that we can't, in fact, put this into a public cloud. We're going to have to put it into a data center, and that's got a set of challenges, right? That's how it ends. And ultimately, this is a go, no go. All these, how does it end? They're go, no goes. People have to feel comfortable. And you can't do them to a calendar. And boy, do people want you to. Like, so could you do an architecture? Today's what? Monday at 3 o'clock for the kickoff meeting. So we'd like an architecture Wednesday, 9 a.m.-ish? No. Step 2. Architecture, design, and technology, right? So our inputs are DDD, the glossary, the tree, and by now we've collected the shop standards and practices, which are a kind of non-functional requirement, right? But they've said, you know, anything from say, I don't know, Microsoft, we have a license for, and we have approved its use from a licensing point of view. InfoSec is happy with it. We have a set of shop standards around it. You know, we have all these other things. You can use this. And you damn well better know that, because I came into a project really late and we went to rock and roll to production, and we were in a review meeting and somebody raised their hand and went, there are 3 unapproved technologies and I don't see any sign-offs anywhere on any of this. I have the power to red flag production. We're not going to production on time. And I looked at the person that I replaced got to participate in the economic opportunity pool, and I think is now embracing a career of waste management. But the thing is, they didn't collect these and use them as inputs for the activities. Oh no, they didn't get put into the tree. Oh, double no. And nobody owned, like, enforcing that. Oh, triple no. So the activities in architecture, design, and technology selection are you have talks and you write things down. And as you have talks and write things down, your tree of work items should get bigger and bigger and bigger and bigger. And work items should have documents attached to them and transcripts of discussions attached to them. Like, why did we go this way? We're going to capture the decision. And we're going to do it in one place by, you know, almost all these enterprise tools have a place to put discussion threads. Put them there. They all have a way to do attachments. Put them there. Right? They all have a way to search for them. Put them there. And then, you know, we're going to iterate and iterate and iterate, and we're going to build out that tree. More than anything, we're going to build that tree. And the tree is going to get decorated, and the ornaments are discussions and documents. And at some point, we're going to be able to ask the question, can we be 80% confident that we have an estimate of cost and schedule? And at that moment, right, we're in a good place. So how do we deal with choosing technology? Because you'll notice in here, technology is not really an output, but it is because it's in the tree, right? We have a document attached to a feature that says, you know, these are the approved technologies. or these are the selected technologies, or these are the technologies that are in my design document, but that are from the approved list. We know that because we had a design review. And one of the things we review in a design review, which is a different video, is this an approved technology, or do we need to go hand in hand? And if the answer to that last question is yes, then we need to stop, drop, and roll, because we're about to make a hideous mistake. Or we're going to have to fight a fight you may not want to fight, and be able to keep your cost and schedule where you think it is. So there are 5 enterprise building blocks in the abstract. And I have a whole video on building blocks, right? We need a place for our code to run. We need a place for data. We need to be able to improve our performance and throughput by having caches. We need queues, events, hubs. We need, messaging, right? We need messaging. And we need network components for it all to sit on. And believe it or not, that actually subsumes about 80% of the use cases. Because if you think about it, if you're using, say, Databricks, we're writing code for Databricks that runs on the Databrick app host. It's an app host. I have code, it runs there, right? So, once you have, as an architect, you should be able to roll those 5 bricks off the top of your head, and, you'll have a session where you have those 5 things as categories on a whiteboard, and you'll start talking about all the requirements and, what the approved coding languages are and what our various problems are, and, this design needs a cache, or this design needs a queue or a data store, or all of the above. And we're going to start enumerating those things. And you're going to narrow and narrow and narrow and narrow and narrow. And there's no point, in picking a technology nobody knows unless you have a startlingly good reason and a plan to either onboard experts in that technology to guide the team or train the team up. Or A and B, which is even better, right? So, and then just make sure what remains meets the non-functional requirements. And don't repeat yourself. Like, if you look at your finished technology list and you've got SQL Server and Oracle and blah, 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 and those things are not integrations, right? They are parts of your solution inside your big bubble, which is your domain, right? Wow, have you done a bad thing? It's different if they're exterior to you and you have to integrate to them. That just is a fact of life. But you should not, succumb to best of breed disease. You'd be amazed how many problems we can solve by drastically narrowing the technology selection. Not only is it easier to operate, but the individual technologiist can truly gain expertise in troubleshooting and scaling and, getting the very best of everything out of that thing. If, we have 5 different database engines, the expertise is going to be spread so thin, it's going to be really shallow too. And I had this argument with my peers all the time. I join projects in midstream and I look at their technology list and I go, what on earth possessed you to have 3 ETL technologies? Why do you have 4 database engines? Why are you mixing and matching this and that? What was the use case? What was your selection criteria? Oh, it was shiny on your resume? Oh, really? Just say no. How does it end? Keep coming back to this, right? You have to know how something ends. You have to. And if the answer is you die of old age or frustration, that's not a good answer. So again, how does it end? When you can have an estimate of time and schedule. And the consensus is you know enough to start implementing, which is, step 3. So in step 3, there are some prerequisite behaviors. And over the years, I've had enormous lists of these. And I have, along with my peers and friends, boiled it down to discipline, cleanliness, and focus. Seriously, it's like the non-functional requirements. I have a YouTube video on non-functional requirements, and we took all the non-functional requirements and all the different standards that are commercially available or in open source or whatever, and we had nearly 100 non-functional requirements. And then we said, well, that's just cray-cray. So we sat down one day and boiled it down to 10. You heard me, 10 unique non-functional requirements. Some of them are kind of generous categories, and a lot of non-functional requirements from other people's lists actually fit into 2 different requirements categories. But that's okay, because non-functional requirements and other kinds of categorical things should be tags on items in our tree. They are decorations. They are not branches or leaves. So, discipline, revise and communicate. Things change. Communicate change. Automate. If you have anything that's manual, you've already messed up. And again, it's got to be in the item tree. And just don't allow people to put anything anywhere else. Now, there is kind of an asterisk to that, and that is if people are building dashboards outside of your tool but using the tool's underlying data, you can kind of tolerate that if it serves a purpose. But most of the big enterprise tools allow you to build pretty nice dashboards. So, maybe that's not such a great idea. Cleanliness. Part of cleanliness is, following the previous rule, is statuses and comments and attachments and all those things. That tree should be squeaky clean and up to date all the time. Don't tolerate it not being up to date. Don't let tech debt build up. Insist on coding clean and requiring pull request reviews. And hold the reviewers accountable. If they let something go through and it turns out to be a horrendous bug or a violation of something, that person should have known. I don't care how busy they are. If their people are too busy to do decent reviews, then we need more people. And then when you're testing things, the number one most important thing are things that impact the user experience, not the UI, right? Which is a graphical user interface or web or whatever. Who cares about that other than the people who are building it and the people who are using it? But what I'm saying is developers have tasks, right? But users have goals. So do goal-oriented testing, right? End-to-end testing, which is not to say that unit tests and integration tests and things like that are not important. They are important. But if you have to give anywhere in your testing budget, don't give up on end-to-end testing. And I have a video on synthetic transactions which speaks to that in more detail. And then focus. Right? Discipline, cleanliness, focus. DCF. Eyes on the prize. Right? Every time you're talking about something, you should have that epic up or print it out where you can read it and go, is that really, really, really germane to delivering the minimum viable product, whatever it is? It could be release 1, it could be release 1.1, 1.2, 2.0, 5.7, who cares? But what is the goal of the upcoming release? And how does it relate back to the epic? And if it doesn't, you should be worried and say something. See something, say something. Better yet, write a memo. Don't let developers over-engineer stuff. It's astounding how many projects I've seen that have built frameworks on top of frameworks on top of frameworks. .NET is a framework. It says so in the name. And yes, there are add-on, bolt-on things to that to make life more convenient. Bolt-ons are cool. Extension is cool, right? Extending things is good, right? From the basic solid principles, open, closed. And again, got a video on solid you can go watch. Don't let people talk you into Yagni. And reject creep. Scope creep, mission creep, creepy behavior. Just don't let it happen. Your implementation will fail without this. DCF. Print it out. Get it tattooed on people's foreheads. Do whatever you have to do to make sure that during the implementation phase, as the project scales out to more and more people, sometimes hundreds, that everybody has an expectation that discipline, cleanliness, and focus are not negotiable. And you're not done until these are done. And together, these represent, in many ways, the definition of done from a non-technical point of view. Obviously, from a technical point of view, there are more things in the definition of done. That's a different video. How does it end? When you ship and actual users can get real work done. That's how it ends. Rinse and repeat. We ship a minimum viable product. Keep saying that phrase over and over again. Every release is a minimum viable product. Users need to get something done. They have goals, right? We can fulfill a certain amount of goals in a certain time period. We want that time period to be as short as humanly possible. I'm on a project now, and they basically ship once a quarter, and sometimes twice. But it's awful because there's too much scope. Lots of little ships with very narrow scopes. And then the user goes to use it, or the integration does a thing, and business happiness ensues. Shipping high quality more frequently is a success strategy. Doing anything else is epic failure. Thank you for your kind attention.